All right, so we started talking about forces, and one concept I want to introduce here is the net force. The net force is the sum of all forces acting on an object, right? So typically, forces are added up to get the net force. So in the same direction, forces add to produce a net force larger than the original forces. In opposite directions, forces add to produce a net force smaller, than the original forces. So, I mean, what does that look like, right? If I have, I'm going to bring my X-wing in again and zoom out a little bit. All right, so if I have these wires hooked up to this X-wing on the wing here, if I just, I'm going to leave one limp here. I'm going to pull along this direction with just this one. Notice how it goes this way, right? If I put these in opposite directions, right? If I were to, now notice both ropes are taut, but it's not moving, right? So my net force is 0. I've got a force pulling to the right and a force pulling to the left. Now, if I allow one to loosen up and I pull, now I'm pulling to the right, right? This force is greater than, or the net force is to the right, right? But I've got two forces acting on this, one to the right, one to the left. Similarly, you can also have forces in one direction, right? So one is limp here, I'm just pulling with one. Now I pull with two, and I'm pulling with, well, an addition effect of the forces. Let me move the paper here. The other thing that's interesting is if my forces are at different directions, right, but not completely opposite, not in the same direction, these are going to produce a net force somewhere in between, right? So you can see I'm pulling these, and the net force, the result is the X-wing's moving straight forward here towards me, even though I'm applying forces at an angle. So forces can add up depending on the direction they're going. We're going to be looking at very simple forces. We're just going to be looking at forces in the same direction or in opposite directions. But in engineering classes, you can get into really complicated directions of forces. So what's the variable for force? Variable for force is F, right? And the units are newtons. So it's an N. Let me just write that in here. And we'll talk about Newton and Newton's laws. There's a reason forces are named after Newton, or the units of force are named after unit, or The units of force are named after Newton because of his contribution to the understanding of forces. So in the SI system, 1 Newton, right, is equal to, remember I said earlier on in the course that you had base units, right? You have mass, you have length, you have time, right? And everything else can be expressed in base units. So the base units for a Newton are kilogram times meter per second squared. So these are the base units, and you'll see how those come about. In fact, the equation for force is just mass times acceleration, right? This is, let me write this in here, mass times acceleration. So that's where that comes from, kilograms times meter per second squared, right? So what does that mean? Well, it means that 1 Newton is the force required to accelerate 1 kilogram of mass by 1 meter per second squared, right? And we learned that acceleration is basically just a change in velocity, right, per unit time. So it's meters per second divided by seconds, right? So it's a change in velocity divided by a change in time. So, you know, every time you accelerate on the on-ramp to get on the highway, right, your car is generating an excess force that's accelerating that mass of the car, right? So if you know your mass of the car and you know your acceleration, you can figure out how many newtons of force the car is generating. So that's pretty exciting, right? So that's a net force.